Good morning, everyone. Welcome to an Elevator World webinar. We're just getting started. Going to wait just a little bit so that everyone gets in and can participate. Really appreciate everyone joining today's webinar presented by CEDES and FIELDBOSS. All right, let's get started. Good morning, everyone. Welcome to an Elevator World Industry webinar. I'm T. Bruce McKinnon. I am the president of Elevator World and your moderator for today's webinar. This webinar is presented by CEDES and FIELDBOSS. CEDES is a global leader in sensor technology and elevator safety systems, while FIELDBOSS is an award-winning all-in-one field service software built specifically for elevator contractors. Today, together, this powerful partnership is delivering smarter, faster elevator service. Today's webinar topic is proactive maintenance redefined, from data insights to field resolution. CEDES and FIELDBOSS connected systems are setting a new standard for proactive elevator maintenance. You'll see how real-time CEDES alerts integrated directly into FIELDBOSS service workflows reduce response times, streamline operations, and improve service delivery. Our speakers today are Santiago Ambula, Vice President of Business Development at CEDES, Poli Rukin, Product Designer at CEDES, and Shani Mehtav, Product Manager at FIELDBOSS. Santiago is a strategy and operations expert with more than 20 years of experience leading successful digital transformation initiatives. His background spans civil engineering, management consulting, and obviously vertical transportation. Poli focuses on designing tools for agile, data-driven maintenance, helping elevator contractors of all sizes achieve scalable digital transformation. And Shani has led key developments in the FIELDBOSS mobile app and customer portal. She is passionate about creating tools that drive digital transformation in the elevator industry. We're also joined this morning by Scott Brown from Elevator World. He'll be monitoring the chat and Q&A section throughout the session. So please post your questions there during and after the presentation, and then we're going to do our very best to let the speakers answer those questions at the end of the presentation. Today's presentation should run roughly 20 minutes, and then we are allowing another 15 or so minutes for Q&A. So feel free to post as many questions as you like. And with that, let's get started, Santiago.
Thank you, T. Bruce. Welcome, everyone. Thank you so much for joining us for today's webinar. As T. Bruce mentioned, we have a partnership going on with FIELDBOSS and CEDES, so we're excited to share with you what we have been working on over the last few months. Today, the topic is proactive maintenance redefined, from data insights to field resolution. And to get started, I just want to talk a little bit about the context of the industry where we're at today. There's a lot of elevator breakdowns and entrapments happening in the industry. It's not news to you, it's not news to the end customers, and we are all trying to work through that by providing, excuse me, better maintenance solutions so that the riding public can be safer, customers can be happier, facility managers can have better running buildings, and then elevator service providers can provide the better maintenance that they want to provide. Now, the context is a little bit difficult in a sense that the ability to service elevators is becoming harder and harder every day, just for the fact of a healthy growing market in terms of new elevators coming online. Also, a large population of aging elevators that exist today, and also a decreasing workforce, which is what we're all going through. And if you ask different maintenance providers, they will tell you that their number one pain point these days is finding and retaining good talent that can provide the maintenance that it's needed. And we don't see that trend changing, unfortunately. And that's where having innovative solutions like what we're presenting today, we believe it's a way to help bridge that gap that will continue to grow just based on the current trends. So what are we doing? So what we're trying to do is moving from the world of corrective maintenance, which is a lot of what people are facing today as maintenance providers, and use data via new technology, call that Internet of Things, for example, to enable these companies and these technicians to provide better preventive and get to predictive maintenance. Now, the challenge there is what to do and where to go and when to go, right? It's not easy to understand that if you don't have access to the data of the elevator on the field that can tell you and provide guidance as to what is going on, what is the health status, if you will, of a specific asset in the field. And when we have a distributed portfolio of units that a company needs to take care of, or a university, let's say, needs to take care of, then having that information at your fingertips, it's very valuable. And that's why we say that we believe using new technologies, you can try to move away from the world of corrective maintenance, putting out fires all the time, and focus more on preventive and then getting to predictive maintenance, right? Where you can have then prediction on where to go and when to go, which is really what we want to focus on. So this is an example, right, in terms of maintenance. What you see here is a real life example of a unit that's on the field, where you can see on each of these charts variations on acceleration in this case, and each of the lines on the chart represents a different floor. So what we're doing really with the CEDES, let's say, solution is we are monitoring the behavior of the door system and also the cabin. In this particular example, we're looking at the door system and how the doors are performing. And this measurement of acceleration is aggregated data that's analyzed on the back end. And it shows you in the first chart on the left, you can see how there's a baseline for that elevator, and then something happened right around the 28th, the day 28th of the month. So we call that an anomaly. We're not trying to look for a specific number on the left-hand side. We're just trying to look for variations on the pattern of behavior of the unit that's on the field. So once you detect an anomaly, ideally, you have the ability to then notify these data insights into a field service management system, in this case, FIELDBOSS. So what you can do with that is then you provide the maintenance company the ability to react and execute the maintenance, then provide feedback as to what was the issue, right? We're not telling the technician what to do. That's what the technician is there for. We can tell the technician when to go and where to go, right? Which floor in particular. In this case, you can see all lines move at the same time. So the only door that travels every floor is the door on the cabin side. So you can already tell the technician that they should go look at the cab door in that specific elevator to try to fix the issue. And then they make the corrective action on the field, hopefully on a preemptive basis, meaning the owner of the building and their end customers are not affected by it, by a shutdown, let's say, or by a door that's not working, therefore preventing additional unnecessary or bad customer experience, let's say, and also a potential safety issue, right? And then after it's corrected, you can see how it goes back to the baseline. So this is what's very interesting about the data and being able to provide the data. Now, excellent to be able to have the data, as I mentioned before, and do some analytics to aggregate the data and then create those insights and data insights and predictions based on that data. But then really the perceived value becomes real when you have this workflow integration, which is really the trifecta between process, people, and technology, which is what we're trying to do with FIELDBOSS. So that if you have this type of information in your system and you can create maintenance action on the field management system, then you should be able to let's say, provide the right information to the best people that's best prepared to answer or to resolve that issue, and be able to then conduct the maintenance action as needed. So that's why we're working with FIELDBOSS to do this. So we want to connect these insights to the actions on the let's say on the field, and provide what we deem a smarter elevator service. So that's why it's important to understand where we're coming from and what we're trying to do. And we want to share that with you today. So an example here of what happens on a day in a life, let's say, of an elevator, when you have data and when you don't have data. In this case, you don't have data, right? Which is majority of the current status for a lot of companies or a lot of facility managers, right? So in this case, for example, the door does not close. Therefore, the tenant is contacting the field manager or the facilities manager with a complaint. So to begin with, it's not a positive situation, a positive customer experience. Then there's a few handoffs until a technician is actually dispatched, which could be actually doing preventive maintenance or scheduled to do preventive maintenance on a different location, and has to drop that to come to solve this issue. Now, the facility manager is not obviously thrilled about the situation, and there could be a number of hours that happen between when the tenant informed that facility manager and when the technician showed up, which is exacerbating the situation. And then when the technician comes in, he or she has to start figuring out or troubleshooting what the issue might be, so he doesn't know where to go. So there's also the potential issue of spare parts or specific tools that they may need to conduct the work that may not have readily available. And then eventually the issue is fixed and it's solved, but then there's a lot of pain, a lot of time going through that process. Now, on a different scenario, or in the same scenario, but when you have data insights of it available, so you can detect remotely that either the door is not closing or there's a trend that will get to that point, like in the example that I showed before. In this case, then the service provider is notified by the integration between CEDES Elevate and FIELDBOSS in this case for what we're going to show you. And then the facility manager can be informed by the maintenance provider at the same time as they dispatch and plan the activity, right? So they have the service provider has the ability to decide whether or not they need to send someone right away, or is it something that can be scheduled for a future activity and the next maintenance visit. Then eventually the technician arrives. If it's something that requires immediate attention, then they will know where to go. In this example that I showed you, go to fix the elevator cabin door, and then fix the situation and provide feedback to the facility manager and to the system, so that the next time that a similar pattern is observed, there could be additional information and in the end improve the machine learning algorithms that are behind these predictions. So by using predictive maintenance, you actually shorten the process of dealing with the elevator breakdown, preventing an elevator breakdown, because you're also anticipating those potential issues before they actually happen, which is why we focus on when and where, not necessarily on the what. The idea is to prevent the what. So with that, I'll turn it over to Shani, who's going to walk us through what are the steps in this particular integration at this point in time.
So before we will show you exactly how it looks in CEDES and in FIELDBOSS, we're going to walk through the overview of the process of the integration. So we start with a detection. So the CEDES sensors monitor the anomalies and the shutdowns, and when a shutdown is detected, an alert is created in CEDES. And once the alert is created in CEDES, that triggers the integration, and the alert is sent into FIELDBOSS. In FIELDBOSS, the office staff will dispatch a mechanic if needed, and they will add additional details. That will create a service ticket for the technician. They will do the work on the mobile app. Then they will update the service ticket and that will trigger two things. One thing is a service review, and then the office will approve the time card, the service activities, and the work orders, and it will also, we will send the invoice to the customer. And on the other hand, there's a feedback loop, and an update will be sent back to CEDES with the resolution of the ticket. So now we can see exactly what it looks like in CEDES and FIELDBOSS, and Polly will show you the CEDES side of it.
Sure. So we launched our collaboration between CEDES and FIELDBOSS, and in this version we started with detecting shutdowns. And before we go into that, I just wanted to give you a quick update on how the shutdown is detected, how is it working, right? So as you know, CEDES collects data through the IoT-enabled sensors that could be installed on every elevators. And we, of course, present the data that we collect, and then also in the background, our algorithms, they analyze and detect the issues. One of those issues is the shutdown. It is detected based on information from previous 16 weeks. So our algorithms understand individual behavior for each elevator, and they predict what kind of rides they're supposed to have during each hour, during each day of week. And then when we don't see, well, when our algorithms don't see that rides, they trigger the alert. This alert is of course shown on the dashboard. You can see like history of those alerts. At the same time, the email communication is sent to the subscribe to notification users, and it's sent through the API to the FIELDBOSS. This is first out of many alerts that are follow during this integration. And in this version, we will focus on also, of course, to enable the link to set up this API so that elevators can talk to each other between the systems. And to set it up, it's very easy. You just need to open the asset that you want to connect in the FIELDBOSS, copy its link, and in technical data in here, put it in this field. That's it. After that, the integration works like magic, and all the alerts are communicated as soon as they are detected. So now I can pass it over to Shani, so you can see how it works on the FIELDBOSS side.
Okay, so after the alert is created in CEDES, after the alert is created in CEDES, we would want to show what it looks like in FIELDBOSS. So in FIELDBOSS, on the side under service, we will see all the CEDES alerts. So here we will see all the alerts. We can see the different office responses. We can see the mobile status. And now we want to see one of these alerts. So this is an example for an alert. So we can see the type. And as Polly said, right now we only have shutdowns, but there's more to come here. We have a link to the device. We can see the office response. So the office staff, when they get this alert, they can either say we dispatch the technician, it's a false alert, or it was resolved in the field if the technician was already there. And we can also confirm the shutdown. So that can be done either by the technician in the field, or the office staff can call the property and make sure that there is actually a shutdown. So now we would want to dispatch a technician. We would go to the dispatch tab, and the office staff can fill in some details like the resource, the start time, and they would click dispatch and create work order and service activity, which will create a ticket that we have right here. So we have a link to the service ticket. We have some additional details, and after it's created, that will be sent to the mobile technician to their mobile app, and we can see it here. So the technician will open the app, go to their service activities. They will do the work that they need to do in the ticket. So they will do all the work. They will clock in. They will click arrived. When they resolve the ticket, they will resolve, clock out. Once they do that, the status will update so we can see the mobile status is done. Once it's done, we know that the job is finished, and we want to make sure that CEDES also got that resolution. So we would go to the alert responses, and we can see the integration and what was sent back to CEDES. So we can see if it was failed or if there was a success in the integration. And that's how we close that cycle that we just went over for the integration. So if any of this was interesting to you, we will dive deeper into this at the NAC at our presentation. So we would love to see you there. And I think we are ready to open for question.
Okay, so we have our first question here. You presented a suspected shutdown type of alert. What other alerts are you working on, and when do you expect them to become available?
So there's a few things on the pipeline, but I think Polly, you're the best suited for answering this. Please elaborate.
So the next one that is coming is the door health alert, which refers to the non-urgent alert that would be one of the tasks during your maintenances, because in this one we're detecting where doors are going a little bit off rails. They are not breaking down right away, but they might within a month or so. So it's better to take a look at it whenever you can, whenever you're in the area. Don't run yet. And then this is supposed to come still this year. And later, we are implementing more alerts, like an urgent door health alert. We're looking into more information about pit and machine room in case you would have additional sensors there. So, but these alerts will be integrated early next year.
Okay.
So it's not just, sorry, so it's not just door sensors. You guys are having sensors placed throughout the system that will communicate these alerts.
I don't know if it was a secret. It's it will be announced as well in NAC, the wireless sensors that we are developing. And yes, at the moment there will be two new sensors, one for pit, one for machine room.
Got it.
Yeah, so the system today is currently using our CEDES technology, which is focused on door performance, but also cabin movement along the shaft. So that's our current capability. As Paul is saying, sort of letting the cat out of the bag a little bit. At NAC, we will be presenting additional pieces that can be integrated into that, let's say, system. And then all the analytics behind it are trying to use as much data as possible to provide better understanding of what's going on the field.
Okay, we have another question here. Ian Mills says he's interested in the sensor systems you use. Are these available in the UK?
The short answer is yes. We are happy to connect you with our UK folks. I think I changed this slide now. You have there our email information. So please feel free to reach out directly to each of us or to the sales teams, to the sales emails that you see on the screen. Also, cheap publicity stunt. We have two booths that are next to each other at NAC this upcoming event in September. So we have CEDES in booth 907 and FIELDBOSS in booth 900. Right across each other. You can miss it because it's right next to the saloon. So if you're at NAC, please stop by, say hello, and we're happy to show you more details on all of this. Back to you, Scott.
Okay. The next one we have here is how does the CEDES door curtain determine the suspected shutdown? Does it mean the unit is out of service, or will it be out of service the next few hours or days?
So I'll take a stab at it, but Polly, correct me here if I'm missing something. Basically, the wait for the suspected shutdown, it's using the historic behavior of the unit for the last 16 weeks. And based on those patterns of behavior, it will have an expectation on when the elevator should be moving. And if it's not detecting the number of, let's say, rides that are expected within a period of time, I believe it's 30 minutes or 1 hour, then it will create the alert. So I can already see Polly raising her hand there. So Polly,
Yeah.
please.
Yes, not that much. Around 30 minutes, because we still want to double check that we do not trigger false alerts. At the same time, that's a good question, right? We're installing light curtains on the doors. Of course, we know the behavior of the doors very well, but in addition to that, we're also installing the box, the gateway on top of the car, which has the SIM card, which sends the information to the cloud and so on. And that box also has the sensors, right? So it detects vibrations of the car. Based on that, we can understand the speed of the car, the rides, the floors, and so on. So we use all the sensors available to us.
Sorry about that. Next question.
All right, so we have here, you mentioned that you've moved the information through the clouds. The specific question we have is, how is data shared from the elevator to the cloud? Is it supplied to the cloud, like all that is collected, or is it conditioned before it is sent?
It's a good question. So basically we have edge devices. So there's some processing that happens on the edge, on the field itself, because it doesn't make sense from a cost perspective to be transmitting all the live data real time. It would be too expensive. And also we have the ability then, because these are connected using a gateway and there's different, let's say, options that based on what your needs are. But the basic, let's say, model has a gateway that is included in the cabin, and then it travels with the cabin. So it also buffers data on the edge, it processes there, and then the next time that it finds cellular connectivity, it will send the data to the cloud to be processed in addition to whatever it already had, and then it's displayed on the dashboard, which is a web-based application, which is what Polly showed on her part of the demo. That's available to the maintenance company, and the maintenance company can decide if they want to make it available to other people like consultants and also the end customers. So the data, let's say the raw data is owned by the customer, of course, but then after it's processed, then it's a value added that we bring to the customer, the service provider, and anyone else that they deem necessary. So how it works is the customer owns the base data, and they provide through the contract the ability for others that they deem part of their team, for example, a service provider, to use the benefits of that data.
Okay. John Koshek here has a couple of questions. Does it sense emergency stops and users jumping up and down in the elevator?
There is, so not on what we showed, but we do monitor acceleration on the cabin as it moves through the shaft, right? So there will be, let's say, spikes that, depending on the duration and frequency, it will or will not get flagged as an anomaly, right? Depending on how persistent, I would say, the anomaly is. So the answer is maybe. It depends, right, on what the actual disturbance may be. Polly, anything to add there?
Yes, so at the moment we are detecting bumps and rollbacks as part of our ride disturbance detections. And bumps will go very close to those detecting jumps in the cabin part of question. And the upcoming feature that we're looking into, upcoming alert, for now internally in CEDES, we are looking into ride health and alerts, right? So there, where we will start investigating that this year and so on.
Okay.
So more to come on that, John, but great questions.
The second question he had is, what happens if the CEDES unit stops transmitting data? Does it alert when it's not connected, or how does that work?
Yes, so we monitor actively the connectivity of the unit, right? And then based on that connectivity being available, then we're able to get the information. But if after a period of time there's no connectivity, let's say established, could be a number of things, right? One thing could be if you're on a, for example, we have several units that are mostly underground. So in those cases, what we have done is not necessarily keep using that data that's very intermittent, but we have moved to a different, more powerful, I would say, gateway and different installation. So you have a static gateway that, by the way, also enables emergency communication and texting and all of that, because it's the same gateway that you can use. But in that case, because it's emergency communications driven as well, you would have to place it either in the machine room with let's say good connectivity or permanent connectivity, or top of the trough, something like that. So we have seen different environments, let's say, where connectivity is a challenge, and there's different ways that you can place, or different locations where you can place your gateway to address that. Now, if there's no connectivity for a number of hours or a long extended period of time, let's say, then we can notify the maintenance provider in this case, or the facilities manager, depending who is the one touching the equipment, let's say, to then figure out a course of action in that case. Paulie, go
Just
ahead.
a side note, system always tracks if elevator goes offline, or if we still see it, it's still connected. So at any moment you can see it on the dashboard. And sometimes, yes, as Santiago mentioned, maybe just a basement, so poor connectivity issue. If we see that elevator goes offline for like longer than 24 hours, we internally start looking into each case and resolving. Ideally, as soon as possible, of course. So our goal that those should not happen, of course.
Okay, and we have an anonymous question here. It says, are you using pattern recognition to determine normal usage? When the elevator ride pattern changes, can you determine an out of service event? What is the precision and recall rate, and how many false positive conditions should they expect?
Sounds like a data scientist is looking at this, which is good. Clearly, I'm not the person that you want to answer that question, so I'll turn it over to Paulie, and then we can connect you, provide more information.
Yes. When ride pattern changes, of course, it might be a little off falling, because our algorithms are smart, but they also human. No, they also allow it to fail, as ChatGPT allows to fail, right? For example, but the benefit is of the interface. You can always see with your human eyes if this alert is actually valid, because you can see that, okay, the pattern just changed, and the algorithm is still changing the wheels, so to say. So yes, we develop the system and we improve the system as we go. Of course, everything needs a few iterations to work perfectly. And well, the most of the shutdowns that we detect are actually very helpful, and they save a lot of callbacks and a lot of issues with the customers. So
yeah, I mean, what I can tell you from our experience using it, part of the question asked about false positives, right? That's part of the reason why we have a delay to check different data points and make sure that we're not wasting people's time on the field, because it's very expensive. As we saw at the beginning of the presentation, that's one of the key gaps that we're trying to minimize or to mitigate, right? So we need to make sure that the information in the dashboard is as reliable as we can based on the data that we see. And that's why we have a team of data scientists behind this. You just see 3 faces here, but really there's a larger team behind us that it's really looking at this day in and day out. So I would say the experience using it with some of our customers already is that they have been able to proactively reach out to facilities managers to let them know things that are of pattern and elevators that are actually down, and proactively, let's say, avoid potential issues with end customers by finding units that are not working, let's say. So at the beginning of the day or end of the day, they look at this data and then are able to either act on notifications for the day, right, or plan early dispatches in the morning to technicians to take care of things ahead of time, and then notify their counterparts or their customers so that they can demonstrate the value added by reducing downtime during office hours and things of that sort.
Okay, we just had another question pop up. Can you please explain how the technicians get the information and communicate? Is it an app on their smartphone? And can they also communicate back from their side, like in case they need support from an expert?
So I can answer this one.
Yes, please, Shani, go ahead.
Okay. So it is a mobile app. It can work on any type of mobile device. It can be a tablet, it can be on desktop, it can be iPhone, Android, anything. And yes, they do communicate back. So we do have ways for them to communicate with the office through the app. So they don't need to call the office and say what they need. So we have something called field request, and there are other things in the app that help them communicate with the office. And you can contact me if you want more information about that.
Okay. And to circle back about the false positives, how many false alarms are running on arrivals have you detected over the past year?
That information, I guess we wouldn't, necessarily disclose it. What I would say is we have been able to identify several cases where there's the shutdown and the unit was actually down. We have documented cases from different technicians, let's say, with one of our key customers that it's already using this. Now, in terms of running on arrivals, is not necessarily tied to the shutdown notification. It's rather the other way around. So in the slides, we were talking about the case where you don't have data, right? So let me go back there. So here you will get someone, being dispatched, right? So if you don't have data, you don't know what's the status of the elevator, right? So let's call it a scenario where you have data, but then the customer initiated the notification, right? Like in this part here on the top, then you can have a conversation between the facilities manager and the call center or the dispatcher who's already seeing data, right? If you have the data, they could have a discussion to say, hey, I already see that elevator 123 at Parker Avenue is moving. The last ride was 4 minutes ago going up. Do you still want me to dispatch John, who's going to be able to get there in 30 minutes? And by the way, based on your contractors, you will have that information from FIELDBOSS. These would be an X amount charge, or maybe it's already included in your contract, depending on what the contract says, right? So you would have additional information to provide better service to the facilities manager in this case, or the owner of the building, whomever is calling with that request. So in that case, you could save running on arrivals, but also justify the expense, right? Because a lot of times with running on arrivals, that's the problem, where someone shows up, it's already the elevator has recovered, and then you don't know what actually happened also, because it's hard to know as the elevator self-recovered, or sometimes the facility manager, someone in the on-site, let's say on part of the facility management team, for example, could be power cycling the whole unit, so you lose also information that may be on the logs and things like that, right? For the elevator controller, which is a precision. This is not about the IoT solution necessarily, the details. We can show you that at NAC, but this is compatible across any type of elevator, as long as you have a motor that opens and closes the doors, right? Other than that, it should be installed. It could be installed across any brand, any model, any age. So it helps you monitor really your portfolio overall.
Okay, next question here. Is there an API strategy to dispatch mechanics using their existing field mobility tools?
We believe, and correct me, Shani, here if I'm wrong, but we believe that the owner of the business needs to make the decisions, right? I don't know if the question was intended to say automatically dispatching people, just based on the data. We're not there yet. I don't even know if that's the direction that we really want to go. When we said earlier, we are focusing on the when and where to go, and we leave the what to the technician, is because we truly believe that this technology should be looked at as a new tool or an additional tool on the technician's toolbox, and is not going to necessarily replace the technician knowledge or the consent or the decision-making power from the office, right? That's going to identify and schedule the technician to be at a specific location. I don't know, Shani, if you see it differently.
I think you said, like, you're not wrong. I just want to add that it is something we can look into if we see that it makes sense for everyone and that the data is reliable. We can rely on it, and we can just send someone automatically. We just don't want to send a technician somewhere where he's not needed. And we would rather spend another few seconds of someone dispatching them and making sure than like sending someone when we don't need to send them out.
Okay, next question we have here. Is there an offline feature when using the app? And is the refresh backup timing a long or relatively fast process?
So yes, the app works offline, and then the moment the user will get back to a signal, then the app will sync. The sync usually takes a few seconds. If you have a lot of data, it can take a few minutes. But the sync happens in the background, so you can still use the app even while it syncs.
Okay, looks like we have one more here, or maybe two more. Does the implementation of the system provide benefits such as reduced current costs? Insurance providers have acknowledged the benefit of a program and resulting operational liability savings and faster annual certification by elevator regulation authorities.
Can you read that again, Scott? I'm sorry.
Oh, sure.
Up a little bit on my end.
Just to summarize it a little bit, does the implementation of the system provide benefits like reducing insurance premiums or increasing the speed of annual certification by regulatory authorities?
It's an excellent question. I think this question is thinking about risk-based management, right? For maintenance contracts and things like that. I don't know of a specific case where that's already happening. I can tell you that because I have a fire alarm in my home, my insurance premium is lower than it would be otherwise. So I think there's appetite for that. I think it's a little bit early in the game to see some financial products already built in with things like that. I believe it's possible because the data is reliable enough to provide additional risk management and risk mitigation, which is what that's aiming for. In terms of inspections, faster inspections, I think it's the other piece from regulators. I think it's early days, but we've seen, let's say, positive comments, if you will, in terms of having this information. If you ask me, what we've seen in other markets, like back to insurance, where regulators have models to measure the risk of a given portfolio for a company, we could think in the future having this information across portfolios and demonstrating an authority having jurisdiction that your portfolio is better managed from a risk standpoint should provide better qualifications, if you will, for that company. Again, I think it's early days, but I believe that is possible, and we've seen it happening in other industries. So I don't discount that. It's maybe more than a couple of years away, but we'll see. It depends also on how regulation is also changing. I think in the last couple of years, we've seen positive moves in terms of adopting new concepts from that standpoint, but still it's the elevator industry, so we are very keen on safety. So also things take time because of that. So we'll see where the market goes on that one.
Okay, the next question we have here is about recurring fees after installation. You know, do you have guidelines for that, the subscription rate, etc.?
Yeah, well, and Shani, I think you also have something to say here. Basically talking about the requirements to be able to access this type of features and data insights, you would have to have obviously FIELDBOSS and also CEDES Elevate subscriptions, right? They are separate products because we also provide the service to other companies that are not necessarily doing the integration yet. So provided you have the two, let's say, applications or the two subscriptions, then this would become part of your features, right? Of the box, if you will, for new subscriptions. In terms of pricing, we're happy to provide you that information offline. I think it depends on your specific situation, right? If you're talking about one elevator, 10, 100, the CEDES Elevate subscription is based on number of units, and FIELDBOSS is based on number of seats because it's a different consumption model. I'll turn it over to you, Shani, in case you want to add something.
Yeah, I think the short answer is if you have both CEDES and FIELDBOSS, the integration doesn't have an additional cost. Yeah.
Correct. Thank you.
And you know, by extension, I guess the next question here would be: do you have any examples of clients currently using this integration?
Yes, we're working with, I would say, one of the largest independent service providers in the US, which is a FIELDBOSS and a CEDES Elevate customer as well, obviously. We've been working with them. Well, each of the companies have been working with them for a while now, and we have been testing with them this feature for a couple of months already with positive results. So the examples that I was mentioning earlier are coming from those initial tests with them, which is now part of their live application. And we're now working towards testing further to extend within their portfolio of companies, let's put it that way.
Okay, that looks like it for the questions. If anybody else attending has anything they'd like to ask, now is your chance. If forever hold your peace. I'll turn it back over to you.
Okay. Fantastic presentation. Really, really excellent and informative. Thanks, Santiago, Holly, and Shani. Had great attendance and questions. So really appreciate everybody attending today's presentation. All who registered and attend will receive a follow-up email with contact information, and you'll be able to also access the recorded webinar at elevatorworld.com under our media tab. Of course, you can reach out to any of the contacts we have here on the screen. And of course, we look forward to seeing all who will be attending the NAEC in September. Thanks a lot, everybody. Hope you guys have a great day, and really appreciate the great presentation.
Thank you, everyone. See you at NAEC.
Thank you. Bye.
Thanks. Bye-bye.
Bye.